Hi everyone, myself Dr. Arun. Today we are going to discuss about balanced slope detector. This is the one of the type of FM detector. It is also called as the balanced frequency discriminator. Now we are going to discuss about the FM balanced slope detector. So the fundamentals related with the balanced slope detector we are discussed in the slope detector video. So those who are interested to know about the slope detector operation, you can refer the previous video. Now we are going to discuss about the balanced slope detector. As per this balanced slope detector also used to detect the message signal from the frequency modulated signal. The fundamental principal operation of balanced slope detector is whatever may be the frequency variation available in the frequency modulated output, that will be converted as amplitude variation. Then that particular amplitude modulated signal will be applied towards envelope detector. Then finally we are getting the message signal. This is the overall outline of the operation of balanced slope detector. So here the primary side of the transformer and the secondary side of the transformer is available. Here the first tuned circuit tuned to carrier frequency FC, and secondary of first or upper tuned circuit is tuned to FC plus del F, and lower tuned circuit is tuned to FC minus del F. So here the R1 and R1 and C1, similar manner R2 and C2, the both the set of RC circuits are used for filtering purpose to eliminate the ripples. So here the final output is V01 and V02 because of the slope detector 1 is V01 and slope detector 2 is V02. The net output is difference between V01 and V02. This entire balanced slope detector we are going to discuss with three different modes of operation to understand how the balanced slope detector is working. Working operation of the circuit operation can be explained by dividing the input frequency into three ranges as follows. So the first mode of operation we are going to discuss now. The first mode of operation we are considering the input signal is unmodulated carrier frequency. So FIN is equal to FC. I am assuming 100 megahertz is the corresponding input frequency or carrier frequency or unmodulated carrier frequency. So here that unmodulated carrier frequency applied towards primary of the transformer. So due to mutual induction, the first tuned circuit and second tuned circuit both are generating the equal potential across D1 and D2. Because both the potentials are equal in D1 and D2, it will generate the corresponding voltage V01 and V02. Both the potentials are equal but opposite in polarity. The net output is 0. Net output of the circuit is 0 if the input is unmodulated carrier or equivalent to carrier frequency. So here we can see when you are going to apply the unmodulated carrier, here I am considering because of the slope detector 1, the net output voltage is plus 5, and the lower slope detector or slope detector 2 generating the output voltage as minus 5 volt. So when we take the difference between plus 5 and minus 5, the net output is 0. This is also explained by using the S-shaped curve. So here the center point is represented, F is equal to FC. So input frequency is equal to carrier frequency. Input to diode D1 and D2 are equal. V01 is equal to V02. The net output is 0. So the y-axis is represented output voltage. So because of input frequency is FC, the output voltage is 0. So now we are moving to the second mode of operation. In this second mode of operation, we are considering the input frequency is FC plus del F. So more than 100 megahertz, more than 100 megahertz. In your frequency modulated signal, the maximum frequency deviation is allowed is 75 kilohertz. So that's why del F I mentioned as 75 kilohertz. So 100 plus 75 kilohertz, this is achieved during positive cycle of message signal at the transmitter side. So this particular part I am considering as FC plus del F. So this particular frequency we are going to apply towards the balance slope detector. Here the FC plus del F, the upper tuned circuit is already tuned to FC plus del F, and the lower tuned circuit is tuned to FC minus del F. So here whenever we are applying the input frequency as FC plus del F, this upper tuned circuit already in the resonant condition, you will get the maximum output voltage. So here it is not a resonant condition because the input frequency is FC plus del F, but here we are tuned to FC minus del F. Because of that, we will get the maximum potential across diode D1 compared with D2. So in this particular situation, we will get a maximum positive voltage due to upper slope detector 1. So the V01 is maximum positive and V02 is corresponding negative voltage. So this is minus 3 we are represented approximately. For explanation purpose, I mentioned as plus 8 and minus 3. The net output difference of two voltages. So plus 8 and minus 3, the resultant output we are expecting as 5 volt positive. So during high frequency input signal, you are getting the positive output. So here in the S-shaped curve representing in the positive cycle, if the frequency is gradually increasing, the maximum frequency we are consider as FC plus del F. In this corresponding situation, the input to the diode D1 is higher than input to the diode D2. V01 is greater than V02. The net output is positive. This is the second mode of operation. Next we are going to discuss about third mode of operation. In this third mode of operation, the input frequency we are considering FC minus del F. This is because of negative cycle of message signal at the transmitter side or during the modulation. So here I am considering 100 megahertz is the unmodulated carrier minus 75 kilohertz, that is the corresponding frequency approximately I am mentioning. So this particular part we are going to deduct whatever may be the frequency variation present in this particular part. We have to convert it as voltage. So here this particular FC plus del F frequency applied towards the primary of the transformer. In the secondary, you can see the two tuned circuits are available. So the lower tuned circuit exactly tuned to input frequency, this tuned circuit will give maximum response compared with the tuned circuit 1. Because of that corresponding resonant condition, D1, the corresponding D1 potential is high, hence the negative output V02 is higher due to D1 is high, and similar manner because of D1 potential is very less compared with D2, the net output of V01 is plus 3, that means lesser voltage. So highest negative voltage and lowest positive voltage. When we are going to take a difference, the resultant output is minus 5. So the same thing is represented here in the S-shaped curve. So FC is the unmodulated carrier frequency. Towards this particular direction, the frequency is gradually reducing. During your negative cycle, the corresponding input to diode D1 is lesser than input to diode D2. V01 is less than V02. The net output is negative. So by using the three different mode of operation, we are able to generate a positive cycle, negative cycle of the message signal by using balanced slope detector. So here the balanced slope detector having advantages and disadvantages. This circuit is more efficient than simple slope detector. It has better linearity than simple slope detector. The linearity is good in balanced slope detector. The drawbacks of balanced slope detector is even though the linearity is good, it is not good enough. We have to improve a lot. So by doing some other technique. So this circuit, another drawback is this circuit is difficult to tune since the three tuned circuits are tuned to three different frequencies. One is FC, another one is FC plus del F, another one is FC minus del F. The final drawback is amplitude limiter is not provided, because if any amplitude variation present in the frequency modulated signal, that will not be considered and eliminated by using balanced slope detector. This will increase the noise level at the receiver side. Thank you for watching this video. We will meet again with another detector in this particular topic. So try to like, comment, share this video. Thank you all.